Hello guys, welcome to Brogrammers. Today we are going to solve LeetCode's problem of the day for today 8 August. The problem states that you are given the matrix with the starting index, okay, which is the row and the column here, row and the column of the rows, total rows and column of the grid is given. The northwest corner is at the first row and the column of the grid, and the southeast corner is at the last row and the column. Okay, so what the question is telling, northwest corner is at first row and column of the grid, southeast corner is at the last row and column of the grid. Okay, you will walk in clockwise spiral shape to visit every position in the grid. Whenever you move outside the grid boundary, we continue to walk outside and return to the grid boundary later. Okay, eventually we reach row into column spaces of the grid. So row into column means the total cell of the given grid. Fine. See, so general thought, whenever we come while traversing the matrix or any grid, is traveling in all the directions, traveling in all the possible directions. Here we are given with the four directions where we need to travel, which are north, south, east, and west. Okay. Now see, let's say you are at 0 comma 0. Okay, and let's say this is for the unit distance which is given as 1. So whenever you go from origin towards the north, okay, you are decreasing the y-axis, okay, and the x-axis, decreasing the x-axis and the y-axis remains same. Okay, so here what we get is minus 1 comma 0. So if we getting minus 1 comma 0 in the north, the opposite we will get in the south, it's plus 1 comma 0. Okay, and similarly for the east we have 0 comma plus 1, and for the west we have 0 comma minus 1. Okay. So this is how we travel throughout the grid, okay, in all the four directions. Now let's come to the question. Question is telling like you have to return every index of the grid whichever you are traveling. Okay, so the output will be all the all the indexes, fine, all the cell index, but in the spiral order. Okay, so one more thing here is first is traversal. Okay, we are going to traverse the grid. Fine. Second is we are going to traverse the grid in spiral form. Fine. So what is spiral? Spiral is like a circular traveling form. Okay. You are traveling the grid circular in the circular manner. Fine. So whenever anything comes where you are going to travel in the circular order, we always take the index modulus of the size. So let's say we have the distance, okay, and the next distance is distance plus 1. So it will go out of boundary, will go out of boundary when it will reach 3. Okay, so when it will reach 3 plus 1 equal to 4, will go out of boundary. So how we will handle this case? When it will go out of boundary, we can't traverse there. So in circular list or in the circular arrays, what we generally do is we modulate it with the size of our behavior. Like we are taking here the four directions. Okay, so we will modulate it for with 4 so that the resultant index which we are getting is in the range of 4, 0 to 4. It don't go outside the range. Fine, so that the next index of the circular is always the first index. Fine, so let's see, this is, let's say this is the array. Okay, this is the array 0 1 2 3. Fine, so 1 is the next index of 0, 2 is the next index of 1, 3 is the next index of 2, and next index of 3 will be a 4. Okay, a 4. So this is the size of the array. Fine, 4. 4 is the size of the array. And after 3, we are going to 4, which is the imaginary index. Now, let's say it's the imaginary index. So, it is going out of bound. See, it is telling it is moving out of boundary grid index. Okay, means it is going out of boundary. Fine. So, when it is going out of boundary, how we will do that this index remain in our range, which is 4, we will modulate it. Okay, 4 modulus 4 is equal to 0. So after 3, rather than going out of bound, it is coming back to 0. Okay, so next index of 3 becomes 0. And similarly, if you go to year 5, okay, 5 modulus of 4 is equal to 1. Okay, so next index will be 1. Fine. So this is the basic understanding of the circular part which we are going to see. Fine. So what we are saying is, let's take these directions here. No, we are working on these directions for now. Okay, fine. We are working on these directions. Now we take a distance array. Fine. We take a distance array and we store all the possible directions here. Okay, fine. So we store all of them in a serial order. Let's take north in the clockwise. Okay, we are doing in clockwise. See, it's given here. We are moving the spiral in the clockwise sense. Fine, we will store everything in the clockwise sense. First north, then east, then south, then west. Fine, we stored it. Okay, now what we will do, we are going to start from the given index, which is r start and r c start. Okay, r start and c start is our index. Fine. Also, one more thing we see here. Let's do some runs here. This is the given matrix we have. Okay. So let's. This is the starting point given here. Fine. After this starting point, it will go towards right. Okay. It will go towards right, and then it will go towards down, and when it will go towards west direction, it increases its length by 1 cell. Okay, so while going east, it, it's okay. While going south, it's okay. But while going west, it's increasing the direction by 1. Okay. Also, by going north, remain in the same direction. Okay. Again, while going towards the east, it increases. Okay, with the see, this is in, so this is increased and this is increased. Okay, so let's take a index. Let's take this is 0, 0 index. Let's take this is 0 index. This is first index, this is second index, this is third index. Okay, so whenever we are traversing over first and third index, okay, it is increasing its move by 1 cell. Fine, it's increasing its move by 1 cell. Okay, now we do this. Now we let's explain this by pseudocode. Fine. So we are starting with our given points, which is r start, okay, and as c start. Fine. With r start, c start is given, row is given, and column is given. Fine. These four things are given. So now let's take our moves as 0. In starting, we have 0 moves and the direction also 0. We will increase the direction. We have 4 direction in total. Okay. We start from the 0 direction. Fine. Now we take a answer. So we are having many. arrays of index stored in our answer. So we take answer vector here and we add the initial starting index, starting cell index. Okay. After adding, see, what should be our output? Our output should be all the cells present in the grid itself. Okay. So how we will count those cells? It is R into C. R is total number of rows and C is total number of columns. Okay. So this is total number of cells in the grid. Fine. So we will do this loop till our answer has cell all the cell indexes, means our answer has all the cells traversed. Okay, till when? Till the row into column. Fine. Till we get every index of the cell, we traverse this. Okay. So also now what we told, whenever it is 0 and third index, okay, it increases its move by 1. See, it increases its move by 1 to 2. Okay. So we take here if direction is equal to 1 or direction is equal to 3, we increase our moves. This will be increased every time whenever you go towards direction 1 and 3, which is given. Now we get the nearby elements or we get the next element. So how we'll get the next element? So the general thought of getting the next elements or neighboring elements in the grid or a matrix is by adding the index which we have here, by adding these index to the current index. Okay, we get our next cell. Fine. So for I from 0 to number of moves which we have, okay, we update our index to this is distance, these index we are updating here. Okay, distance of direction. Okay, this is the direction and this is a 0. See, we are updating this is row. Okay, so in this you see this part is row and this part is column. So row is 0th index and column is first index. Fine. So now we updated our column here. Okay. So after this, we check whether it is going out of bound or not. Okay. If so, for checking in any matrix, it is going out of bound. It should lie in the range from 0 to the given row size and the given column size. Okay. So our row should be from 0 to the given row size and our column should be in the given column size. Fine. Okay. So after moving to the next all the indexes or the next cells, we change our direction. Fine. Okay. So after this bond, when it goes, we check the last one. It is in the range or not. If it is in the range, then we add those to our answer. Okay. And we change the direction. See, we are in the spiral, which is circular. We use modulus to change the direction, uh, to update the index. Sorry. Okay. So after this, we get or we return it we return our answer. Okay. If you want, then you can use for loop to get all the elements. If you want to see the log. Okay. So this is our pseudo code which we wrote. Let's revise it. And now we are using moves. We are initializing moves and directions with 0. Okay. This is our answer vector, and we push the start from where we start traversing, and this is where we stop condition, where we are stopping when all the elements or all the cells are being traversed, then it is stopped. We This is the of the direction update of direction moves. Okay, so when it is moving this side, then it goes one more cell which is from this side. Like if this is two cells, then when it's going in the left or towards the west, it is going for three cells. Okay, so this is the condition where we are doing this, and this is the condition. This whole condition is to get all next cells. Okay, while traversing. Fine, and this is the update the direction. Okay, see, this is going this side, then this side. Okay, this is updating. After going there, it will again update here. Okay, so this is going out of bound. So after going out of bound, again it should enter here. Okay, as it is circular, so always if we mod it, then it will again come in the range we have, which is row range matrix. We have four direction, it will come here, and we return the answer. Okay, if you have any issues, then you can drop in the comment section. Okay, so first of all, we are creating the direction array, which we are taking like north, east, south, and west. Okay, and then we are initializing the moves and the directions, and we are creating the empty array list for the storing all the cell indexes. Okay, this is where we are initializing, or we are storing our first start cell index. Okay, and now we are traversing all the cells till our answer size is less than row into column. If direction is 1 and 3, means direction is north or south, or our direction is east and west, then only we are increasing our moves. Okay, and this code is for moving to the neighbors, or moving to the next cells. Okay, so we are updating our start column and rows, and we are checking if it is in the our given boundaries. If the cell index is in given boundaries, then we are adding it to the answer, and after that we are updating our direction, and modulus of 4. No, I told you, which keep it within the range, and now we are getting all the indexes and we are printing it. Okay, so this is the code now. Thank you.